Here we have problem number 8. We have spherical symmetric object with radius r is given, the mass is given, its rolls without slipping across horizontal floor with velocity is given. It then rolls up inclined with an angle of inclination theta and comes to the rest distance at 3.8 meter up the incline before reversing direction and rolling back down. Find the moment of inertia of this object about an axis through its center of mass. Okay, so basically we have the object which is rolling at the same time is moving with initial velocity. So it goes up and then it stops. So we have to find what is the moment of inertia of this object. The first of all, energy here is conserved. Okay, initial energy is equal to the final energy. So what is initial energy here? The initial energy will be translation kinetic energy and the rotational kinetic energy of the object. Translation kinetic energy of this mass will be mv initial squared over 2 and then plus the rolling or rotational kinetic energy, which is 1 over 2 I omega squared over 2, and this is equal to the potential energy, which is mg h final here. Okay, we also know that omega is basically equal to the omega itself is equal to the v over r in formula. Okay, so we have to replace that one to v initial over r, we have here, and then it's equal to mg h final. So from here first let's find the moment of inertia, where it shortens to this formula I v initial squared over r squared to mg h final minus mv initial squared. Okay, from there we have to find I, so this r initial r squared multiplies here, and then v initial 1 divides by this one, so we end up with this formula. And since we have to calculate h final, so the h final is basically equal to the d distance multiplied to the sine 37 degree. Okay, so you take this one and plug it here, or plug it here, so it becomes d sine 37 degree minus v initial squared and all this thing, and then you have to plug the numbers and you will get the answer.